I'm Jerry Porter, and I'm the chair of the program committee for PASEF this year, and I'm glad to welcome you to the final lecture of the term and the final lecture of the calendar year. Our speakers today, I think, have an interesting topic. Let me tell you a little about each of them. Gino Segrè came to Penn in 1967. He's now Professor of Physics Emeritus. In addition to his career as a high-energy elementary particle theorist, he served as chair of the physics department for 5 years, collected various fellowships and awards from Sloan, Guggenheim, Rockefeller, the NSF, and DOE. Away from Penn, he served a term as director of theoretical physics at the NSF. Physics, he says, is his family business. He married a physicist's daughter. His brother is a physicist. His brother-in-law is a physicist. His nephew is a physicist. Several cousins are physicists. Not to mention that his uncle is a Nobel laureate in physics. After about 15 years ago, a long-term interest in history led him to begin taking time from physics to begin some writing. There was another reason as well. After 30 years of specialized research, he wanted to try thinking about science in a broader context. Bettina Hoerlin, the daughter of a physicist, is not a physicist, but she is an author. In 2011, she published Steps of Courage, My Parents' Journey from Nazi Germany to America. How that came about is another story that you can ask her about. She earned a doctorate degree in public policy and taught public health at Penn for 17 years, served as health commissioner of the city of Philadelphia, and was a visiting professor at Haverford College. Enough about them. Let's hear about the Pope of Physics, Enrico Fermi, and the birth of the atomic age.
Well, thank you I should speak into the microphone here. So thank you very much for coming. It's a pleasure to be here. And I would like to give one special welcome before we start to one of our most distinguished emeritus faculty members who is here, and that is Eli Burstein in the back with Rena. Eli is also one of the founders of the Modern Physics Department, and Eli will be 100 next year. So let's have a special welcome for Eli and Rena, and wish them many more visits to luncheon talks here or other venues at the university. So, who was Enrico Fermi? Well, first of all, he was the greatest Italian scientist since Galileo. He's really the founder of modern science in Italy. He was also one of the 20th century's greatest physicists, and the only one to really reach the very peak as both a theorist and an experimentalist. His contributions to the world of science are multifold, including in his early 20s being a contributor to really our modern views of quantum mechanics, the world we live in, of electronics, etc. Owes much to Enrico Fermi, as does some of the later developments we will talk about. So, Bettina and we wrote a book about this called The Pope of Physics, and we'll tell you it got cut off. It's Enrico Fermi and the Birth of the Atomic Age. So we'll tell you in a little bit why he was called the Pope of Physics. So let's start. We're going to alternate talking. That is, Bettina will talk for a while, then I will, and then back and forth. So, Bettina.
Okay. We're not altering words, it's only paragraphs, so don't get worried. Let me make sure. Whoop, okay. So, with all good stories, this one begins with birth, and Enrico Fermi's parents, Alberto and Ida Fermi, and they were just had reached the middle class. The father, Alberto, was with the civil service system, he was with the railroad system, and his mother was a teacher. Neither of them had gone to university, but they were upwardly mobile. And here are their 3 children. They had 3 children in succession, 1, 2, 3, every year. And as you can see, the middle one is Enrico there, clinging to his older brother. In those times in Italy, the following was not unusual. We've all heard of wet nurses. Can everybody hear me, by the way? Great. We've all heard of wet nurses coming into homes. One of the things maybe you haven't heard about quite as much is what happened to Enrico Fermi, and that he was farmed out. He was literally farmed out. He was brought to the country, and he lived with farmers for the first 2.5 years of his life. His mother had felt overwhelmed with the 3 children. She wanted to continue teaching, and therefore he lived with this family on the farm. When he came back, reunited with his siblings, and it was probably around this age, he looked around at this apartment in Rome, he looked at his siblings, he looked at his parents, and he burst into tears. Seems to me a very natural reaction. And his mother said to him, "We'll have none of that in this house. Only naughty children cry, and you have to stop crying." And he did stop crying. And I mention that because I think it's such a poignant example of emotional oppression. And he learned, Enrico Fermi, through his life, to, in fact, oppress his emotions. He kept them inside. He was very close to his brother, his 1-year-old brother, and when Enrico was 13, his brother had tonsillitis, had an infection of the tonsils, was brought to an emergency clinic just to have an abscess drained, and lo and behold, died on the operating table. This was a tragedy. This was felt very deeply by the whole family. His mother never recovered from a deep depression. The family really stayed in a grief-like trance throughout Enrico's younger years. Again, just to show how much he withdrew, how much he wanted to control his emotions, which his mother had suggested he should do. He walked by the clinic where his brother had died a week afterwards to make sure he wouldn't cry when he did so. That's emotional control. Enrico grew up, and as he grew up, more and more he withdrew to the world of mathematics, science. This was a rational world. This was not an emotional world. And he became insatiable. He read everything. This, you may recognize, is a photo of the Campo di Fiori in Rome. And in his time, the Campo was really mainly bookstalls. So what does a teenage kid, 14-year-old, do on a Saturday with his good friend? You wander around the Campo, you maybe get a gelato, but not Enrico, he didn't get a gelato. What he got was a 900-page work on science that was written in 1830 by a priest, and it was in Latin. Isn't that what every 14-year-old dreams of? And he lugs this home, the whole 900 pages, and he reads it ferociously. And he had this way of committing whatever he read to memory. He was quite phenomenal that way. A family friend was very concerned about him because he knew he was growing up in this depressed household, and also knew that he was very bright. His parents didn't seem to recognize that. The school didn't even seem to recognize that. But this friend said, this is a very bright child, and I think he should apply at age 16 to the Scuola Normale Superiore, which was the elite school in Italy at a university level that was associated, in this case, with the University of Pisa. Highly competitive to get in. And they just allowed 40 kids a year to get in, and throughout Italy in all kinds of disciplines. So he went and he took the 3-day exam. And at the end of the 3 days, an examining professor from Rome, a physicist, called him into his office. Well, can you imagine a 16-year-old being called by the Herr Professor in? And the professor said, you wrote this answer that is very interesting, meaning phenomenal. Do you really understand it? And Enrico had to justify that answer, and lo and behold, he could, whereupon he was instantly granted admission to the Scuola, which was a tutorial program as well as room and board. Universities did not have room and board. So he was one of the 40 students, the only physics student that was chosen that year. There was only one problem at the Scuola and at the university. Nobody could teach him anything. Italy was a total backwater in terms of physics, and there was no one there who could teach him anything. So this whole effort that he had about reading everything that he could get his hands on was continued. He, in fact, read everything he could get his hands on in the library, whether it was in English, French, or German, and he read all three fluently. He was self-educated through and through. But luckily, what the university did give him, and the Scuola did give him, was an opportunity to have some fun, which was certainly not the case before, and to make friends, and to be silly and make jokes. And he was climbing mountains with friends, he was skiing with friends, he was swimming with friends, and he was always the first up the mountain. He always hiked the fastest, he always swam the hardest. He was highly competitive. At the same time, he was very considerate of other people who were on the hike, on the swim, etc., and took care of them. But he was the leader, definitely the leader. And one of the people who noticed how nice he was, and he teased, and everybody loved him, was a woman named Laura Capon. And this is her. One of the favorite haunts of Enrico in the summer was to go to the Dolomites. And he had actually met her 2 years before 1926 and had absolutely fallen in love with her, thought she was the most gorgeous thing ever. She had looked at him and she said, well, he has exceedingly thin and fleshless lips. But somehow the relationship survived. She recognized other things in him. And they fell in love in 1926. She was from a Jewish family. She was from a well-to-do Jewish family, very different than Enrico's upbringing. But they were able, it was an assimilated family, religion was not an issue. Economics was not an issue because Enrico at that point was considered by everyone, not just the professor at the Scuola Normale, as he was considered as a genius. And they knew that he was going to have a very bright future. He was the hope of Italian physics. In 1926, his promise came true, and he was offered a professorship at age 25 in Rome, and it was the first chair of theoretical physics. With that professorship, simultaneously, actually it wasn't with it, but simultaneous, he acquired a bébé Peugeot, which he would zip around in, adding a lot of zest to that romance because most of the time it broke down. But they had a great time together, and lo and behold, the next year, the two of them got married. This is in front of City Hall in Rome. And the person who steals the scene, at least in my eyes in this, is the gentleman all in white. And that gentleman is an admiral of the Navy, and it was Laura Capone's father, a Jewish general who had made, admiral, sorry, who had made a fabulous reputation in World War I, had become head of Navy intelligence after the war, and in 1928, little did he know that 10 years after that, he would be treated very differently by the Italian government. But this was their wedding. A year after that, Enrico, and here, let's see, yeah, I can do it, hooray. There he is, was made a member of the Italian Royal Academy. This was an academy of Mussolini's making. He wanted to showcase Italy. He wanted everyone to know what brilliant people there were in Italy, and he tapped Enrico Fermi to be one of those people. And look what you got. You got a plumed hat. Who could resist this? You got a cape. You got a sword. You got a lot of prestige. And one of the other things that you got was a stipend. And the stipend, in fact, doubled Enrico's university salary. Most of the people who came to these meetings, and they were always asked to dress this way, came with a chauffeured limousine. But Enrico came in his Peugeot. He was not someone who liked pomp and circumstance. So what that enabled in terms of that money was that Laura was able to continue living in the custom to which she had become in the style to which she had become accustomed. So they lived very comfortably, they lived very well, they had 2 children. Here you have Nella, who was born in 1931, and baby Giulio. They were aware that fascism was increasing, but they had very good lives. In fact, Enrico was building up a center in Rome, which Gino will tell you more about, that rivaled the world's greatest physics centers at that point. Things were going well. And he was apolitical. He had joined the Fascist Party in 1929, shortly before he became a member of the Royal Academy. 1929, joining the Fascist Party was not considered such a big deal. And his feeling was that I'm really just a physicist. I'm not interested in politics. I'll do what I have to, but I'm not really interested. It's a world I don't know. And I would stick with physics. As a father, he was very often absent. He was fully engaged in physics. Not, again, unusual for that era. He worked extremely hard, just like he had hiked harder than anybody else. He worked harder than anybody else, and to build this group via Penn in Rome. And he was awkward as a father. Here you can see him holding a baby. This is an awkward position. He's not cuddling the baby. They're holding the baby like that, not unlike the way, he held this sheep. So these pictures were in fact on the family mantle. There was some joking about it, rightly so. But he was known as an unengaged and rather aloof father. His children suffered from that later and talked openly about it. But again, not so unusual for the times. He believed in physics, pure and simple. Well, one of the things in writing this book with Gino, I can convince everyone here that physics is not simple, and it's not always pure. I'm sorry. Here we go. There we go. This is Hitler, Mussolini showing Hitler Italian troops in 1938. I don't know who the guy on the right is, but he's quite gorgeous, don't you think? And the troops look a little less gorgeous, but Mussolini was trying to show off the prowess of the Italian army. And anti-Semitism was increasing in Rome, and people were wondering in Italy whether, in fact, Italy would go the way of Germany. And they said, oh, not Italy. It's been much more open than Germany, different history. But lo and behold, in 1938, the edicts came down, the anti-Semitic edicts. No Jews were allowed to teach. And although Laura had been very reluctant to leave Italy, she now understood for her sake and for her children's sake that she had to flee. Enrico had wanted to leave before then, actually. He had been to the United States a few times. He had been first the summer of 1930 with Laura, and he immediately took to the United States. She did not. And he came several summers after that to the United States. But he respected the fact that she wanted to be close to her family. But he also saw that physics in Italy was suffering because the people who came to his great center from all over Europe so many of them were Jews who had fled Germany, who had fled Hungary, who had fled Europe in general, and Russia as well. So he knew things were changing, and he wrote, the summer of 1938, he wrote to 5 universities in the United States saying, I'm seeking a professorship. All 5, and he mailed the letters at different villages in the Dolomites so people wouldn't catch on to what he was doing. And he got answers very promptly from all 5 of them. All 5 of them offered him positions. He took the position at Columbia, immediately writing the chair at Columbia saying, there are other physicists here who are Jewish who will need jobs. Can you help them? Now, his escape route was a rather unusual escape route from Italy. How do you leave Italy in 1938? Well, you pick up a Nobel Prize in Stockholm. That seems to be the answer. So the family left Italy, not telling people they weren't returning. They left their apartment as if they were returning, and they traveled to Stockholm for Enrico to pick up the 1938 Nobel Prize. And here he is on the left. When Gino and I were going through this, I said, oh, I'm going to have to tell people who this is, but I bet this group knows. Who won the Literature Prize in 1938 in Stockholm? Pearl Buck. Pearl Buck, there she is. And Pearl Buck almost got Enrico Fermi in her lap when he backed, as he should, away from the king when he got his prize and almost sat down on her, but somehow it got avoided. And here on the right, you see him receiving the actual prize from the king. He was roundly criticized in the Italian press because he was not wearing the wonderful uniform. They didn't know he wasn't coming back, right? He was not wearing the wonderful uniform of the academy, and he had not given the fascist salute. That's what made the Italian newspapers. Not that he had gotten the Nobel Prize, but that he had not been proud to be an Italian at the ceremonies. The Fermi family left, arrived from England, arrived in the United States early in January 1939, and Enrico turned to Laura and said, we have now founded the American branch of the Fermi family. 2 months after they had arrived, he was working with a group of physicists in Columbia, but also Princeton, etc. Somebody said, somebody has to warn the United States government in 1939, early, that we think Germany may be making an atomic bomb. Fission had been discovered. And they said, Enrico, you do it. You've just won a Nobel Prize. They'll be impressed by you. So somewhat reluctantly, because he was always reluctant about politics, Enrico went down to Washington to meet with an admiral. And as he was in the waiting room, the desk officer went back to announce him, and he could hear the announcement being made, which was, "Admiral, there's a WAP outside." Luckily, he did not get too insulted. Want to take over?
All right, thank you.
Maybe he didn't know what a WAP was. That could be. I never thought of that. Go down here.
Well, having been born in Italy, I've occasionally been referred to as a WAP myself, so. As I said, this is about now Enrico Fermi, the physicist. In the 1920s, he was already regarded as one of the greats of theoretical physics. The field was being revolutionized by people who were in their 20s, and that generation was led by, in particular, a group of four, all born at the beginning of the 20th century. They were an Austrian, a German, an Englishman, and an Italian. The Englishman Paul Dirac is not in this picture. Here are the other three, Fermi, Heisenberg, and Pauli, together in a boat on Lake Como in early 1927. With quantum mechanics, as I said, Fermi had established himself and established also Rome as a great center for theoretical physics. But unlike any of the others, he had always wanted to be an experimentalist as well. And he started already in his college years, and he maintained that attitude throughout his life. But how? How was he going to establish Rome as a center of experimental physics? Well, with the end of the 20s, the focus of physics moved away, at least in part, from the atom toward the nucleus, the core of the atom. And in particular, with the discovery of the neutron in 1932, sometimes called the dawn of modern physics. As I say, here's a picture of Fermi, though, backing whether theory or experimental physics. He always had his little notebook with him and his slide rule in his pocket. He was the consummate calculator. He always wanted to make an estimate of the order of magnitude of any phenomena. This is him on a walk in the country. The chance to become a nuclear experimentalist came in the 30s. At the end of 1933, the beginning of 1934 was when he established himself as an experimentalist. But before he did that, he solved one of the great problems in theoretical physics, namely the nucleus. After 1932, it was understood that the nucleus is made up of neutrons and protons. On the other hand, there was a puzzle. The puzzle was that electrons seemed to come out occasionally of the nucleus, but how could electrons be coming out of the nucleus if they weren't in there to begin with? Fermi formulated a theory. Okay. The theory said that occasionally neutrons decay, they change their spots. It would be like, I don't know, a zebra's running across the plains and suddenly changes into an antelope. Okay. The idea of particles changing identity was not part of the baggage of physics. But here he introduced it. The theory that he formulated, you can read there this is a description by Marvin Goldberger, a man who was one of his students after the war, later a professor at Princeton, president of Caltech, etc. What he said is also could be taken as a description of Fermi. No smooth talk, no pretensions, no promise that this is the first of a long series, etc. Just the facts. Okay. This theory has stood with some modifications to this day, and is regarded as one of the great triumphs of theoretical physics. But this was Fermi's year, and Fermi said, theoretical physics is great, but I want to be an experimental physicist as well. And what was his vehicle for that? Well, once again, it was the neutron. People had started bombarding the nucleus and see what happens, create radioactive isotopes. He said, I can make a beam of neutrons. Nobody had ever scattered neutrons effectively off a nucleus. He started doing this in 1934, only 2 months after the formulation of this theory, and the first paper on the subject was published in March of 1934. He realized then that he had discovered a new technique, a new window on the world of the nucleus, and they needed to systematically explore it. That is, they needed to bombard with neutrons, hydrogen, helium, lithium, etc., all the way up to uranium. This is a big enterprise, and it needed a team to do it. So he went around his physics department in Rome, assembled the team, and here are the first 5 people who joined him in that team. They were called in Italy, I ragazzi di Via Panisperna, the boys of Via Panisperna being the street in Rome where the physics department is. Yeah, Jerry said that my uncle got the Nobel Prize. Yes, he's the second over there on the left. He got really lucky. He would have been quite a good engineer, but in 1927, when he was a third-year engineering student, the head of the physics department of Rome says, we've just hired this great young physicist, but there are no students. Any engineering students want to switch over to physics? So he raised his hand, and that was one lucky switch. So here they are. They were a young bunch of people, and they were very playful. They worked together, they went for hikes together, and they took nicknames together. So what was Fermi's nickname? Well, this was Rome. He was infallible, so he was nicknamed the Pope. And others had nicknames, the Cardinal, the little boy. My uncle had a bad temper. He was nicknamed the Basilisk, a fire-spitting monster. But the man who provided them, for instance, with the neutron beam, provided them with a radioactive material from which they made the beam. They nicknamed him Divine Providence. Okay? So they all had, and that's the way they referred to each other. So, maybe I should back up a second. They proceeded to do all these analysis of their scattering experiments. And then, in the fall of 1938, Fermi made a second discovery. Namely, it was always thought that the harder the projectile, the more likely you will be to create something different, something new. That was true for the previous bombardments of nuclei, but he said neutrons are likely to be more effective if they're slowed down, because slow neutrons will just creep into the nucleus. As they make their way through, they will wreak havoc, that is, create new isotopes, etc. So slow neutrons is the technique. This was the second great discovery of 1934, second great experimental one. And this is what he eventually won the Nobel Prize for. But he missed something. And he not only missed it, but everybody else missed it. Because this experimental technique that he had pioneered was taken up in Paris, Berlin, Cambridge, New York, California, etc. But they all missed something. And what they missed was that when neutrons, there's a little neutron coming in, hits a particular isotope here of uranium, it can actually cause that nucleus to fission. That is, to break into two smaller nuclei, and additional neutrons can be created. This was not discovered until the end of 1938. In fact, somewhat embarrassingly, the announcement was made as Fermi was collecting his Nobel Prize. Fission changed the scene, okay? Because it also became clear that if you could produce fission, you can do more than that. If you pack lots of uranium together, you could initiate fission here. Whoop. There we go. You have one fission, but more neutrons are produced. If they hit other uranium nuclei, then they will fission. And each time you have a nucleus fission, a lot of energy is produced. These two fragments in the fission emerge with a great deal of energy, as I said. And, well, Fermi said, I particularly like this because you can produce a very intense beam of neutrons and do some wonderful physics with it. Well, that's true. But you can also do something else. Okay. And that we'll talk about in a minute. So he started doing experiments involving fission as soon as he got to the United States then, as soon as the news of it reached in the fall of 1939. And he started to build what he would call a pile, a large collection of uranium nuclei embedded in graphite. So graphite was there to slow the neutrons down to make the fission more effective. But as we all know, on this very day in 1941, World War II started for the United States. Namely, the United States entered war, and shortly after that, there began to be, well, there already had been, but the realization was more evident that fission could be used to make a weapon. A big laboratory was set up in Chicago called the Metallurgical Laboratory, and they decided to see if they could assemble a pile and have a sustained nuclear chain reaction. Here's a schematic picture of the pile. It was originally going to be built outside of Chicago. There were labor troubles. Fermi said, went to the head of the metallurgical lab, Arthur Compton, and said, I'll build it with my team inside a squash court underneath the football stadium at the University of Chicago. Compton was the head of the metallurgical lab, said, if you build a sustained nuclear chain reaction and we lose control of it, what happens? Well, bad things will happen. But we're not going to. He didn't say, because I'm Enrico Fermi and I'm infallible. But that was the subtext. Compton decided, do I have to tell the president of the university? Well, I better not. Because if I tell him, he's going to say no. And we really need to do this. So they went ahead. In a little under 3 weeks, they assemble this. This is 45,000 20-pound graphite bricks, each one of which has a hole drilled into it for a little sphere of uranium embedded in it. This was built, of course, in secret. These rooms were unheated. The building of it was called not with blueprints, but with black prints, because everybody was covered with graphite dust. And I think they kept a canary in the corner to make sure that it didn't die, so that they would know it'd be okay. On December 2nd, 1942, everything was ready. The pile was kept from going critical by having control rods. That is, rods that absorb neutron were inserted. When the experiment was ready, they began slowly removing the rods. Here's a picture of what, there were no photographs. Here's a picture of what it looked like. This is the balcony of the squash court. Here you see Enrico Fermi. There's electronics. There's about 40 men in here. And there is one woman, Leona Woods, a 23-year-old who later did a considerable amount of work with Fermi. You can just barely see her head right here. But in fact, her voice was clearly heard during that day because she was the one reading out the numbers from the counters. At 3:50 in the afternoon of December 2nd, Fermi checking things, and he says, it has gone critical. Okay. And then he says, let's check that there is an exponential growth of neutrons, as I expect there should be. So he's following, and he's checking that it follows that curve. People are quite nervous. A little bit after 4 minutes, he says, reinsert the rods. Okay? Eugene Wigner was a physicist there. He had bought a fiasco of Chianti. He pulled it out, got some paper cups out, people took a sip, and then he had everybody sign the fiasco. At that point, Compton went to his office. He was the head of the metallurgical lab, and he called Washington. And he gave the coded message, which said, the Italian navigator has landed. The reply from Washington was, is that so? Were the natives friendly? And he said, yes. Everyone landed safe and happy. So, the atomic age was born. Hello there.
Okay. So this was the birth of the atomic age. And prior to this experiment that was so suspenseful and dramatic in Chicago, people had said, we're going to do this. There was great faith. And what kind of planning can we make to change the United States into a giant factory? How can we build a bomb sooner than Germany is going to build a bomb? And there was great concern about that. So in the early 40s, people started talking about how to organize for this. And in late 42, from 1942 to 1943, early 43, within a period of about 5 months, the Manhattan Project, as we know it, came into being. The Manhattan Project was many different sites. The Met Lab was part of the Manhattan Project, but it's mostly known for 3 sites: Hanford, Oak Ridge, and Los Alamos, W, X, and Y sites. And for each of those sites, Enormous pieces of land were built, were bought. These were remote sites. These were sites that would be out of the public eye, and plans were made to develop communities. Communities up to 50,000. It became more than 50,000, in fact, at each of these sites. And this was done with incredible speed, and the scope of this project was huge. It was the biggest governmental enterprise ever. And it was all done in secret. I don't think that could happen today. It was a unique partnership of academia, of industry, and of government. Not sure that could be done today. So the Manhattan Project was well on its way with this. As I said, secrecy was the main thing. This is a sign from Hanford. What you see here, what you do here, let us stay here. The men working, and they were mainly men, working on this project were told not to talk to their wives about what they were doing. Fermi was given a bodyguard who accompanied him everywhere. He was given a code name of Mr. Farmer, not Italian navigator, but Mr. Farmer. Niels Bohr became Mr. Baker. Everybody was given code names. Fermi, in 1942, when he was given this bodyguard, it's a far cry from 1940, when the United States Army had said he is a security risk, he was a member of the Fascist Party, we can't have him working on this project. In 1941, of course, he was an enemy alien, as anyone who was part of the Axis powers was. So this was a very secret project. The Fermis did not come to Los Alamos until 1944. There's his daughter, Nella, with her pass at that point. And Los Alamos was a gated city. You needed a pass to get in. So people occasionally ask me, where did you grow up? And I say, I grew up in a gated community. So it gives new meaning to a gated community. So it was an incredibly ugly place in a beautiful setting. It was an army base. And here's what it looked like. And these are the kind of barracks that the Fermi family moved into, that Laura moved into with the kids. She was given army cots. She was given a pile of blankets and sheets that said used. And she was actually kind of concerned about that. You know, this is kind of tacky, used. Until somebody explained to her that used stood for the United States Engineer Detachment. So Los Alamos was a very hierarchical society. It was a very male-oriented society. And it was a society where people respected the secrecy and worked extremely hard. Here's a briefing at Los Alamos of physicists. And these were to give people a sense of the import of what they were doing. Here you see Fermi. Here you see Oppenheimer, Norris Bradbury, who later became director of Los Alamos, Richard Feynman. These are names very familiar to us. And you can see the serious mood. The average age of scientists at Los Alamos was 29. Fermi was an old guy there. When you think about the future and who was holding the future, it was a very, very young group. They were ready on July 16th for the test that would set off the first nuclear bomb, and that was at Trinity in the desert, south of Los Alamos, very remote part. It was a highly successful pilot in terms of the bomb. Here is a monument that stands there today. Very simple kind of monument. It's a missile base, so it's only open a couple times a year. We were privileged to be able to go there. When this bomb went off, it had been built in a tower, Oppenheimer, the director of the project, who was always very poetic, very learned, quoted from the Sanskrit scriptures, and he said, "I am death, the destroyer of worlds." Ken Bainbridge, another physicist who was there, was a little less prosaic, and he said, "We are all now sons of bitches." And Fermi, true to form, had torn up pieces of paper, and when he realized that the aftershock was about to hit, he threw them up in the air to see how far they would travel, because then he could measure the strength of the blast. And as usual, the Pope was quite correct in his measurements. But that was him, always measuring, not involved in the emotional side of things. Prior to that test, there had been meetings, government meetings, about what, it seems we're really going to build this bomb. What are we going to do with it? And there was controversy within the scientific community about assuming that there was a successful bomb built and detonated, what should be done next. And there was a group at Chicago led by James Frank who said, we need a demonstration. We need a demonstration in a remote site. Let's invite Japan and some other countries, and they will see the power of this weapon and the war will end. And there was another group saying the Japanese are stubborn. They are not going to end the war. They might think we only have one of them. We need to use this. We've committed so much time and resources. We need to stop this war. Our boys are going to get killed. And this was the controversy. So there was an interim committee that had been formed, a government committee, and as part of that committee, there was a scientific panel. There were 4 people on that panel: Fermi, 2 other Nobel Prize winners, and Oppenheimer. And those 4 people were asked to advise the interim committee on where the government should come out on this debate. And this is part of their report. And as you can see, what they basically said is, we don't think this kind of demonstration will bring an end to the war. We see no acceptable alternative but direct military use, meaning that they would drop a bomb on a civilian site, on a Japanese city. At the same time, they were a little bit, I think, circumspect, because they said, of course, we as scientific men have no proprietary rights, no special competence to make this decision. They were saying, this is how we feel in terms of the technical aspects of this decision. And Fermi had been very much involved in that process. Hiroshima, as we know, was August 6th. The people, and followed by Nagasaki, it was the same number of deaths that had been involved in the fire bombings of Tokyo and of Dresden, but it was death by a very different means, and it was death by a single bomb, and our world had changed. Yeah.
Okay, thank you. The war ended then on August 15th, with the war over.
You just speak up a little.
Yeah, Fermi stayed for a few more months in Los Alamos. At the end of 1945, the family left. He had accepted a professorship at the University of Chicago. They were making a major growth in science, and Fermi would be the centerpiece of the build-up in physics, including the hiring of many people from Los Alamos. So Fermi went to Chicago. And what sort of physics was he going to do? Well, just as he had moved from atomic to nuclear physics in the 30s, he decided now he was moving toward a new frontier, and that frontier was going to be high energy or elementary particle physics. It was an age in which bigger and bigger cyclotrons were being constructed. One was built at the University of Chicago. Here he is in the control room, and he went back to being just a physicist. He became a leader in this subject during these years of the late 40s, early 50s. And he returned to teaching. Teaching had always been an integral part of his life. He was a famous, clear lecturer, teacher. He would not only conduct classes, he would meet with the students at all times of day. His door was always open. He tended to get up at 4 in the morning, work for a few hours, come to the office then at 8, and he was available for consultation most of the time. He would have night seminars with his students, he'd go for walks with them. And he gathered this group of people around him. The first slide will be some of the people who either studied with him, worked with him, talked with him, came to be with him in Rome. The next slide will be a parallel one for Chicago. So here's the Rome group. As you can see, many of these names are foreign, are of people who came to Rome from the north of Europe. The ones highlighted in green got Nobel Prizes. Here's the group in the United States. Again, the ones highlighted in green won Nobel Prizes. He had altogether some, depending on how you counted, some 6 or 10 Nobel Prize winning physics students. Many of those who didn't get Nobel Prizes, quote, are just as good, or I say, as those who got the Nobel Prize. I see David Balamuth smiling and agreeing with me there. And he was at the very height of his powers. We're talking about 1954. He was the most eminent physicist in the United States in terms of influence. Of course, the most eminent one was Einstein, but just in terms of influence on the community at large, Fermi was number one. Here's a picture of him and Laura that same year, Fermi with his usual slide rule. She's there having a page from a book she had just written called Atoms in the Family, My Life with Enrico Fermi, which she published in 1954. Strangely enough, she thought it was a bestseller. It was serialized in parts in the New Yorker. Everything was going great. In the summer of 1954, they went to Europe. He was going to lecture at 2 summer schools, one in the French Alps at Les Houches and the other on Lake Como. During his lectures, during his stay on Lake Como, he began to suffer from acute gastric distress. He would stomach aches, vomiting. He carried on. Nevertheless, in September, when he came back to the United States, he thought something is seriously wrong with me. He went into the hospital at the University of Chicago. This, by the way, is just a picture of him on a boat late that summer. You can see he already does not look too well. He was diagnosed with metastatic stomach cancer. There was nothing to be done for it. People were grief-stricken. Here he was, all of a sudden, seemingly dying. And so there was this parade of people who came to see him in the hospital. Fermi, of course, died the way he lived. He was a rational man, remained completely rational to the end. There are stories. One of his colleagues came in the day after the announcement was made that he had this inoperable stomach cancer. The great physicist Subramanian Chandra Sekhar, came in, and when he saw Fermi in the hospital bed, he couldn't speak. And Fermi said, "It's all right, Chandra. Maybe the next time I'll come back as an elephant." You know? And Chandra Sekhar relaxed a bit, and then they started talking about physics. He went home to die. Laura had rented a hospital bed. He said, "You will not need to rent it beyond the end of November. My estimate is I will be dead by then." He had a fatal heart attack on November 28th, 1954. So, last slide. At the site where the football stadium has been torn down, the squash court is gone. A plaque was erected there, and here's a statue by Henry Moore, which was placed at the site where the pile was built. The statue is called Nuclear Energy. It's 12 feet high, 8 feet in diameter. Some people think it looks like the mushroom cloud. Some people think it looks like a skull. Laura Fermi was not particularly happy with it. She did not want Fermi's legacy to be that of the mushroom cloud. What is Fermi's legacy? Well, of course, his legacy is of being a great physicist. Beyond that, Bettina, I leave it to you to think what his legacy is. I should add, if you want to know more about this story, and now shamelessly I will announce we have some books for sale outside in which you can find out more about his legacy. So, thank you very much.
Thank you for a great talk. I'm sure you'll be glad to answer some questions.
Sure. Interesting experience to write a book with your wife or partner.
We've not divorced. Yes.
Could you describe where Leo Szilard fits into this drama?
Well, Leo Szilard is, of course, in a way, the hero of Richard Rhodes's monumental book, The Making of the Atom Bomb. And Leo Szilard.
We can't have the microphone.
Thank you.
Gino.
Leo Szilard and Enrico Fermi are in some ways opposite. Leo Szilard was always political. Fermi tried to be as apolitical as possible. Fermi believed in working manually harder than anybody else. Leo Szilard was almost thrown out of the University of Chicago faculty club because he refused to flush the toilets. He said, "That's maid's work," you know. He was Leo Szilard was a visionary. He was somebody who thought about political implications. He was always 4 steps ahead of everybody.
Maybe that's my cue to jump in while Gino's coughing. I think one of the differences is not only that Szilard was so political, but also that Szilard was really kind of eccentric. And one of the things about Fermi is he was a really normal guy. I remember in Los Alamos meeting him on a hike and it was with these other physicists, and he was the one who said, "Oh, this is kind of a normal guy. I like him. I was a teenager. I like normal." So now I go for eccentric more. But anyway, so I think that's also one of the differences. But he was always pushing Fermi, and was a little upset with Fermi that he wasn't more political.
You described very well his emotional distances and the ability to insulate himself from political affairs. But The thing I found the most surprising was that what happened to Laura's parents didn't penetrate that. Is that, do you have any understanding of that?
I'm sorry, what happened to what?
To her father, to Laura's
To her
father.
father?
Yes.
Oh,
I would have thought that that would break through the shell.
yeah. It's very interesting. In her book, Adams and the Family, Laura does not mention the death of her father. It was like people weren't dealing with it. I think in many cases, the way to deal was not to deal.
Bettina, might I interrupt? For those of you who don't know, most of the Jews in Italy went into hiding. Laura's father, Admiral Capone, says, "I do not need to hide. I am an admiral. They will recognize who I am." The Nazis, of course, after Italy surrendered, the Nazis took over Italy. And at that point, they began deporting Jews. And so Capone said, "I'm a high officer," and they said, "We don't care who you are, you're a Jew." And he was taken and he died in Auschwitz. So that's the...
But Fermi wrote a letter to, do you remember who it was to? And he wrote and he said Lala, which was his wife's nickname, is very upset about the death of her father because they had figured this out toward the end of the war. He didn't say we were upset. Interesting. Yes?
Two things. One, he was self-educated, he was closed down emotionally,
Yeah.
yet he apparently was a tremendous mentor. Is that a contradiction, or is that in a consistent way? And the second question is, he was apolitical in terms of general politics. How did he deal with the famous Bohr Einstein, in a sense, civil war with the physics? Did he get engaged in that? Did he avoid it?
Well, let me address the first and you take the second. He was loved by his peers. He was loved by his students. And I think one of the things that was very difficult for his children is they would see him going off weekends with his students and laughing and having a great time. He wasn't going off with them. He knew how to interact with them. This was his life. This is how he defined himself. This is how his world, and it was a world that he was very comfortable with. It seems a little strange, but I think it can be explained that way. Do you want to go to the second part?
Yeah, he was, I would say that he was always available, always somebody you could always go talk to. You would get an answer for him about any physics problem, theory or experiment. We've talked to people who knew him at that time, and they said he was the go-to guy. So if you're 22 years old or 23 years old, that's what you love in an older mentor. On the other hand, what somebody said, he was great. We all loved him, but he wasn't the sort of person you would go to if you had a personal problem.
Yeah.
Well, that's consistent. As for the Bohr-Einstein split, this was largely about the interpretation of quantum mechanics. And Fermi was not all that interested in this kind of discussion. He said, "I like to solve problems. I don't want to have discussions about the ultimate meaning of quantum mechanics."
Talking about the conflicts, how did he deal with the Teller-Oppenheimer split on the building the H bomb?
Well, he was a consultant on building the reluctant to be a consultant. He was on an advisory panel to the Atomic Energy Commission. He resigned from that when he could. He made fun sometimes of scientists who walk the halls of power. That was not his style. I think he had appreciated Oppenheimer. I don't think they were close. When the Oppenheimer trials came out, he was heard saying to somebody, why didn't they pick on a nice guy like Bethe, you know? But now, of course, we all have to back Oppenheimer because this is outrageous what they've done. And he testified in favor of Oppenheimer at the Oppenheimer hearings.
But he had been close to Teller, but he was appalled by Teller during the Oppenheimer hearings. And Teller was actually one of the people who visited him after he had said to Gino's uncle, I'm dying, I would like to see Teller. His friendship meant a great deal to me. So that's what happened. Teller came to see Enrico at his deathbed, essentially. And it's in the book, the scene. And Enrico basically forgives him, but says, you have to go out there and make some amends. So it was a complicated relationship, close to Teller emotionally, not to Oppenheimer, but did the right thing in terms of supporting Oppenheimer. Other questions?
So let me thank you again.
Well, thank you.
Let me invite you all to our next talk, which is January 11th. Beth Simons, who is the Andrea Mitchell Professor of Political Science and Law, will be speaking on international law and human rights.